So what we're going to take a look at on page 111 is some shortcuts we have for derivatives for looking at sine and cosine. So very similar to how we have shortcuts for polynomial type functions, we're going to have shortcuts for derivatives for trig functions. Now they are going to involve, I'm going to go through kind of what the derivatives for sine and cosine are. I do not expect you to remember the process or the mathematics that I go through to get these, but we do just have to remember or recognize the result derivative in the end. And in order to develop the derivative for sine and cosine using our limit definition of a derivative, we're going to have to use two identities. Now there were many identities that you went through last year in your pre-calc class, and these may look familiar or maybe they don't, but we're going to use these two today as we go through these derivatives. So what they're basically saying is if you are adding two things within a cosine or a sine function, you can break up those two quantities as such. So if you're adding two things within a cosine function, you can use this identity, and then if you're adding two things within a sine function, you can use this identity. Unfortunately, whenever you're using a sine or cosine or any trig function, you cannot simply distribute the cosine or trig function into those two quantities. So I wanted to make sure that we understand that whenever you see this, it is not cosine of A plus cosine of B. Okay, it does not work that way. Very similarly to how you have like a square root. If you did x plus 2, that would not be the square root of x plus the square root of 2. Okay, you cannot break it up in that fashion. Very similar to this idea. So let's first check out the derivative for sine. So using our long definition for the derivative, we'd have sine of x plus h minus sine of x all over h. Okay, so applying that limit derivative to this function, it would look something like that. Notice how if we have two things being added within a sine function, we can break that up using this identity. So instead of a's and b's, we're now going to have x's and h's. So we'll have sine of x cosine of h plus sine of h cosine of x. Okay, so that's just how this first piece would expand based off of the identity. We still have to subtract sine of x, and this is all over h. Now, what I'm going to do from here is just rearrange a few things. I'm going to take these two terms on the end and just switch where they are written. So I'm going to have sine of x cosine of h, and then instead of this middle term, I'm going to write minus sine x, and then I'll just have the sine of h cosine of x left. So I'm just rearranging some terms. Now the reason I want to do that is because notice how for these first two terms, they both have a sine of x in common. So I can technically factor that out, and I'd be left with cosine of h minus 1, because notice how if you distribute that back in, you would have what you have in the previous line. And then I have plus sine of h cosine of x, and all this is over h. Okay, again, I'm hoping we can follow what's going on here, at least the mathematics behind it. I do not expect you to be familiar or remember how this is going. I just want us to be able to recognize and understand each step in finding this derivative. Now the next thing we can do is notice how everything is being divided by h. So if you're dividing by one term, you can break up the individual terms in the numerator. So I'll have sine of x times cosine of h minus 1, and that's all over h. And then I can break up the other term over h as well. And if you take a look at what we have now, since our limit is going towards 0 for the h value, we can use some of those trig limits that we had in the last unit. 1 minus cosine of h, or if you were to flip it, simply take out a negative, that's going towards 0. And notice how sine of h over h would be going towards 1. So if we're left with sine of x times 0, that's technically going away. And in the next term, we'd have 1 times cosine, which is simply cosine. So notice how in the end, the derivative of sine is actually cosine. So we'll write that at the bottom of the page. Here you see that derivative notation again. Again, this is just telling you to take the derivative of whatever's inside the parentheses or the brackets. So if you were to take the derivative of sine of x, you would get cosine of x. All right, let's go ahead and do the same thing for cosine. We'll do the long limit as h approaches 0. Now I'm going to erase some of this just so I have room. All right, so applying our derivative limit, we'd have cosine of x plus h minus cosine of x all over h. It's going to be a very similar process. We're going to apply the identity at the top because there's how we're adding two things together. So using the cosine identity, just with x's and h's this time, we'd have cosine of x, cosine of h, minus sine of x, sine of h, and we still have the subtraction of cosine of x on the end. Again, I'm going to switch the order of these two terms. And the reason I want to do that is because since both of these have a cosine of x in common, I can factor that out. And very similarly to before, if both of these terms are being divided by h, we can break up each term so that we can divide each one individually. So take a look at what we have. Remember, our limit is going towards 0 for the h's. So cosine of h minus 1 all over h, that's going towards 0. And then sine of h over h, that's going towards 1. So it looks like we're left with cosine times 0, which is 0, and then we have to subtract sine of x times 1, which would be a negative sine x. So in the end, if we were to take the derivative of a cosine function, we'd be left with negative sine x. Okay, again, I don't expect you to remember the mathematics behind it. I just wanted to show you how, if we were to apply that derivative limit, this is what we would get in the end. So from here on out, we can just remember these as our shortcut derivatives.